Some of the toughest field structures ever built did not come out of modern camping stores or survivalist manuals. They came out of necessity on the battlefields of the World War II. When soldiers had to create shelter in places where supply lines were thin, storms were constant, and terrain refused to cooperate, they developed a pole-based framework that was far stronger and honestly more durable than canvas tents. This system held against tropical cyclones in the Pacific, freezing winds in Europe, and sandblasting desert storms in North Africa. It was so simple that two people could set it up with basic tools, yet so effective that some of these improvised shelters stood for months without failing. The strange part is that most people today have never even heard of it. The system was born out of military engineering departments that needed shelter that could be built quickly, last long, and withstand violent weather. Unlike tents that rely on flexible fabric stretched over aluminum poles, this structure relied on interlocking wooden or metal uprights anchored deeply and reinforced horizontally. It functioned more like a semi-permanent field outpost, stable, rigid, ventilated and repairable with local materials. Soldiers used it for command posts, medical stations, supply caches and makeshift barracks. When hurricanes hit remote island outposts in the Pacific, these pole systems outlived nearly every canvas structure around them. Their strength came from a combination of simplicity and smart physics. Stable triangles, deep anchoring, cross-bracing and load distribution that prevented collapse. The pole system relied on structural triangles rather than flexible poles. The genius of the World War II pole system was that it avoided the weak points of typical tents. Standard tents rely on bending poles that flex under pressure. This system avoided bending altogether. Soldiers used 3 or 4 upright poles driven into the ground at angles that created rigid triangles. These triangles resisted lateral movement, which is, exactly what destroys tents during storms. When a force hit one side, the pressure was dispersed evenly through the frame. Anyone wanting to replicate this today can gather straight saplings, fence posts or sturdy timber and sink them at least a foot into the ground. The deeper the anchor, the more force the structure can tolerate. By placing poles in triangular formation and connecting their tops with tightly lashed crosspieces, the builder creates a structure that does not sway. If you have paracord, strong rope, or even green vine material, the effect is the same. The stability comes from physics, not complexity. Cross-bracing gave the frame hurricane resistance. The second part of the system involved cross-bracing the poles to prevent twisting. Soldiers lashed diagonal supports between the uprights, turning the structure into a miniature skeleton of a military observation tower. This prevented the poles from shifting in opposite directions during high winds. The result was a rigid frame that held firm even when pounded by sideways rain and flying debris. So, a survivalist or homesteader can actually apply this by lashing a diagonal pole from the bottom of one upright to the top of another. Even a single diagonal brace, massively increases structural integrity. In practice, 2 braces on opposite sides really do transform the frame into a storm-proof skeleton. This is, frankly, one of the main reasons these World War II shelters survived hurricanes when normal tents shredded instantly. A durable roof system, quite simply, prevented uplift during storms. The roof was, another reason for the system's legendary durability. Instead of just stretching canvas loosely over an A-frame, soldiers would pull it tight over a heavy ridgepole and then secure the edges to the ground, using long stakes hammered deep. This tightly stretched fabric created fewer pockets for the wind to grab. In extreme environments, they'd add a secondary layer, maybe palm fronds, brush, or even a tarp, over the first layer to weigh it down further and, to help divert rainwater. These days, someone can build a weather-resistant field shelter by tightening a heavy-duty tarp over the ridgepole and staking it down so firmly that, honestly, the tarp behaves more like a skin than a loose covering. Wetting the tarp just a bit before tightening can help eliminate slack. For long-term shelters, adding a layer of branches or thatching over the tarp prevents UV breakdown and strengthens the wind resistance significantly. Load distribution prevented catastrophic collapse. One of the reasons modern tents fail so quickly in storms is that they depend on tension alone. Once the tension fails in one point, the entire structure collapses. The World War II pole system distributed weight across multiple supports, so, even if one pole loosened, the shelter remained functional. The design also handled vertical loads incredibly well, which is actually why these structures could hold up under heavy rain, wet foliage, and strong downward pressure. A practical method for modern users is to build the shelter so that the ridgepole rests on at least 2 load-bearing uprights, with additional poles supporting the sides. The more upright supports there are, the more force the structure can tolerate. When the frame carries the load rather than the covering, the risk of collapse, it drops dramatically. The system really thrived because it adapted to the materials available, making it incredibly versatile, actually. The most remarkable thing about this World War II system is that it required no specialized parts at all. Soldiers just used whatever the battlefield provided: bamboo in the Pacific, birch in Europe, even scrap lumber from crates in North Africa. The structure was not defined by what it was made of, but by how the poles were arranged. This made the system universal and, timeless. Today, someone working off-grid or preparing emergency structures can apply the same principle. Saplings in a forest, PVC poles in a backyard, metal rods from a salvage yard, all can become part of a storm-resistant shelter. The technique teaches that structure matters more than materials. Once you understand why it works, you can adapt it in dozens of ways. There is real value in learning forgotten engineering that, surprisingly, still outperforms much of our modern gear. Modern tents are designed for comfort and portability, not battlefield survival. The World War II pole system reminds us that durability often comes from ancient, simple principles. Deep anchoring, rigid frames, structural triangles, cross-bracing, and roofs that shed force instead of catching it. When practiced today, the system becomes a reliable method for hunting camps, long-term bushcraft shelters, emergency storm setups, and off-grid living. If you found value in this forgotten wartime engineering and want more historical methods that still serve survivalists today, make sure to subscribe, leave a comment, and share this video with others who appreciate real tested knowledge.